For more than 400 years, since Galileo first turned a telescope towards Saturn and glimpsed something strange surrounding it, astronomers have studied that planet's rings without ever fully understanding one basic, nagging fact about them. They are young. Not young in the sense of decades or centuries, but young on a cosmic timescale, forming somewhere within the last few 100 million years, at a point when dinosaurs were already walking the Earth, rather than during the solar system's actual birth 4.5 billion years ago, the way most planetary rings are generally assumed to form. For years, nobody had a fully satisfying explanation for why Saturn's most famous feature was, relatively speaking, a recent addition. Nobody could explain why the planet itself tilts at a strange 26.7-degree angle, a tilt too large to be produced by any of the ordinary processes that shape planets as they form. And nobody could explain several genuinely odd features scattered across Saturn's family of moons: Titan's strangely smooth, crater-free surface, its bizarrely drifting orbit, or the small, oddly shaped moon Hyperion tumbling nearby. In February of 2026, a team of scientists proposed a single, unified explanation connecting every one of these separate mysteries at once. And the answer involves an entire moon that no longer exists, destroyed in a collision so violent it reshaped Saturn's entire system, and whose physical remains, astonishingly, may still be right there, orbiting the planet today in the form of its rings. To understand why this specific explanation genuinely matters, you first need to understand just how many separate, previously unconnected puzzles Saturn's system actually presented to the scientists studying it. NASA's Cassini spacecraft, which orbited Saturn for 13 years before its deliberate final plunge into the planet's atmosphere in 2017, gathered exactly the kind of precise measurements needed to finally reveal these problems clearly. Toward the end of its mission, Cassini measured exactly how mass is distributed within Saturn's interior, data that controls the planet's slow gravitational wobble through space, a motion astronomers call precession. Using this data, scientists confirmed that Saturn's spin axis had, for a very long stretch of its history, remained locked in a stable, resonant relationship with the orbit of Neptune, a genuine, long-term gravitational partnership between two planets sitting on opposite ends of the outer solar system. But that same Cassini data revealed something else entirely, that Saturn and Neptune are no longer in that resonance today. That something, at some point in the relatively recent past, broke this ancient multi-billion-year gravitational relationship apart, and nobody had a fully convincing explanation for what that something actually was. In 2022, a research team led by Jack Wisdom, a planetary scientist at the Massachusetts Institute of Technology, proposed an answer. Using detailed computer simulations, Wisdom's team suggested that Saturn once hosted an additional moon, one they named Chrysis, that had helped maintain this long-standing gravitational balance with Neptune for billions of years. At some point, they proposed, gravitational interactions with Titan destabilized Chrysalis's orbit, sending it on an increasingly close series of approaches to Saturn itself, until the planet's own powerful gravity finally tore the moon apart entirely, roughly 160 million years ago. According to this model, some of that shredded material scattered inward, eventually settling into the bright, icy rings we still observe surrounding Saturn today, while the loss of Chrysalis's gravitational influence simultaneously knocked Saturn's spin axis out of its ancient alignment with Neptune, producing the planet's current, unusually large tilt in the process. Wisdom described the appeal of this scenario directly, noting that the previously unexplained young age of Saturn's rings fell naturally, out of this proposed sequence of events, tying together two of the planet's biggest mysteries with a single underlying cause. There was, however, a genuine problem with this original hypothesis, one that Wisdom's own team readily acknowledged. The specific sequence of events required for Chrysalis to destabilize, approach Saturn at exactly the right angle, and then get torn apart cleanly enough to form the rings we actually observe today. It turned out to be, in the researchers' own later assessment, disappointingly improbable, a scenario that could technically work, but that required a fairly narrow, specific set of circumstances to actually happen the way the model proposed. This is precisely the gap a new study, led by Mattia Chuk at the SETI Institute and published as a preprint in February of 2026, ahead of its acceptance for publication in the Planetary Science Journal, set out to address. Chuk had actually been approaching this same broad puzzle from a different angle entirely, focusing not on Saturn's rings directly, but on a small, strange, irregularly shaped moon called Hyperion, tumbling chaotically in an elongated orbit near Saturn's much larger moon Titan. Chuk had calculated that Hyperion must have settled into its current, unusual orbital configuration within roughly the past 400 million years, a time frame strikingly similar to the same general window during which Saturn's resonance with Neptune is believed to have broken down. Recognizing this overlap, Chuk explained his own thinking behind connecting these two previously separate puzzles together, noting that a colleague had wanted to tie the ring formation event and the Saturn-Neptune resonance breakdown together directly, while Chuck himself suspected that Hyperion's own strange, relatively recent orbital history offered a more direct, more specific clue to what had actually happened. Working from this insight, Chuck and his colleagues proposed a considerably more specific and considerably more violent version of events. Rather than a single lost moon simply drifting too close to Saturn and being torn apart by the planet's own gravity, their new simulations suggest Saturn once hosted an additional moon roughly 4 times more massive than the originally proposed Chrysis, an object Chuck has taken to calling Proto-Hyperion, describing it vividly as essentially a smaller version of Titan itself, roughly 1,000 times more massive than Hyperion's current, considerably diminished form. According to this refined model, rather than approaching Saturn directly, this massive proto-moon instead collided head-on with Titan, Saturn's largest and most significant satellite, sometime between roughly 100 and 400 million years ago, depending on the specific simulation parameters used. The consequences of a collision this size, according to Chuck's modeling, would have been genuinely catastrophic and remarkably far-reaching. The impact would have stripped away much of Proto-Hyperion's own mass, with the surviving remnant settling into the small, oddly shaped, chaotically tumbling moon we now know as Hyperion. Titan itself, meanwhile, would have absorbed a considerable portion of the impactor's material directly, an event violent enough to completely resurface Titan's own crust, wiping out essentially all of the ancient impact craters that would otherwise be expected to still exist on a moon this old, and explaining, for the first time, exactly why Titan's surface appears so surprisingly smooth and youthful compared to what its actual age would otherwise predict. The same collision, Chuck's team proposes, would have also violently disrupted Titan's orbital path around Saturn, providing a direct physical explanation for why Titan continues drifting steadily outward from Saturn today, migrating at a measured rate of roughly 11 centimeters every year, a rate of orbital drift that has itself puzzled scientists trying to reconcile it with straightforward, undisturbed orbital evolution over billions of years. And the debris scattered outward from this same violent collision, according to the model, did not simply disperse into empty space. Consistent with detailed physical simulations of large-scale lunar collisions conducted in separate research, most of the debris produced by an impact this size would eventually have reaccumulated back together into surviving moons. While a smaller but still substantial portion of that same scattered material would have remained in orbit closer to Saturn itself, gradually settling into the icy, reflective ring system we still observe wrapped around the planet today. In this refined version of events, Saturn's rings are not simply the shredded remains of a single doomed moon torn apart by planetary tides. They are the leftover debris field from a genuine collision between 2 much larger bodies, one of which still survives today, badly damaged and permanently altered, orbiting Saturn as the moon we call Titan. It is important at this point to be genuinely honest about exactly how settled this specific explanation actually is, because that honesty is precisely what separates a fascinating, well-supported scientific hypothesis from a definitively proven fact. As of the study's initial announcement in February of 2026, this specific research had not yet completed formal peer review, though it had already been accepted for publication in the Planetary Science Journal, a meaningful step toward broader scientific acceptance, but not the final word on the matter. Scientists not directly involved in the research have nonetheless responded with considerable interest and genuine credibility. Carl Murray, an emeritus professor at Queen Mary University of London, who worked directly on the Cassini mission team, though not involved in this specific new study, described the overall scenario Chuck's team proposed as complicated, but highly plausible, closely matching the full range of unusual features scientists currently observe throughout Saturn's system. Murray also noted something important about the broader context surrounding this research, explaining that astronomers had long suspected Saturn's entire system had continued evolving considerably since its original formation, but that determining exactly how much change had actually occurred and through what specific mechanism had remained a genuinely difficult, unresolved problem for years. This proposed collision also fits neatly alongside an entirely separate, independently confirmed pattern of discoveries about Saturn's broader family of moons, one that has been unfolding steadily over just the past several years. In March of 2025, astronomers confirmed the discovery of 128 previously unknown small moons orbiting Saturn, pushing its total moon count dramatically ahead of every other planet in the solar system. Then, in March of 2026, an additional 11 small moons were identified by a research team led by Edward Ashton at the Academia Sinica Institute of Astronomy and Astrophysics in Taiwan, pushing Saturn's confirmed satellite count to 285. Nearly all of these newly discovered moons are small, irregularly shaped bodies, orbiting at considerable distances from Saturn, frequently in retrograde directions running opposite to the planet's own rotation, exactly the kind of debris pattern researchers generally associate with the aftermath of ancient collisions between larger moons that once orbited much closer to the planet. Mike Alexanderson, an astronomer at the Center for Astrophysics involved in analyzing these smaller moon discoveries, has directly connected this steadily growing population of small, irregular satellites to the same broader collisional history now being proposed for the rings and Titan themselves, suggesting Saturn's system has experienced considerably more violent, transformative events throughout its history than scientists previously assumed. Step back and consider what this entire body of research, taken together, actually suggests about a planet most people think of as calm, stable, and essentially unchanged since the early solar system first formed. Saturn's rings, among the most recognizable and most photographed features in the entire solar system, are not ancient leftovers from the planet's original formation, but comparatively recent debris, quite possibly younger than many species of dinosaurs that once walked the Earth. Titan, Saturn's largest moon, and one of the most scientifically compelling destinations currently under consideration for future spacecraft missions, may owe its strangely smooth, crater-free surface and its bizarre, ongoing outward drift to a violent collision that occurred well after Titan itself had already finished forming. And the small, chaotically tumbling moon Hyperion, along with hundreds of other small, irregular satellites only recently discovered orbiting Saturn at considerable distances, may all represent scattered physical remnants of the exact same catastrophic event. Fragments of a lost world that once orbited alongside Titan, now broken apart and redistributed throughout Saturn's entire system. So here is the honest, complete picture of Saturn's biggest proposed secret, laid out plainly rather than overstated. A team of scientists has proposed a single, unified, genuinely compelling explanation connecting several of Saturn's most significant, previously unexplained mysteries: the young age of its rings, its unusually large axial tilt, Titan's smooth, crater-free surface and drifting orbit, and the strange, battered shape of the small moon Hyperion, all traced back to one ancient, violent collision between Titan and a since-destroyed companion moon, an event that may have occurred as recently as 100 million years ago. This explanation has not yet completed the full scientific review and confirmation process, and it continues to be actively refined and debated among the researchers studying it. But it already represents one of the most comprehensive, most broadly explanatory theories ever proposed for how Saturn's entire system actually came to look the way it does today. And it suggests that the rings so many people have marveled at through backyard telescopes for centuries are not some permanent ancient fixture of the solar system at all, but the scattered, still settling debris of a genuine planetary scale collision, one whose true story scientists may have only just begun to properly piece together. If you want to see how this theory develops as it continues moving through formal peer review and further study, subscribe and turn on notifications, because Saturn's rings may be quietly telling us the story of a moon that no longer exists, and researchers are only now finally learning how to read it.